revising everything we have done so far in functions and relationships. This is our last lesson on this course before we move on to algebra. And so we're recapping everything that we've learned. Now, I've said it already, but I'm going to say it again. If you are struggling with this section, I would really encourage you to go and watch both the videos on functions and relationships, but also the videos on number patterns. They are very, very closely linked to each other. We've done a lot of the same things in both. So if you go and watch those two, hopefully you'll feel a bit more comfortable with this section. All right, but like I say, we're going to recap everything we've done. So nothing new, just making sure we understand. Sorry, I just need to clean my camera. Alrighty. So if we have a look at our very first situation here, we have got a relationship expressed by a table, and we wanted to go and answer a bunch of questions. So the first thing is we've been given a table. We can see that we're missing some values in our table. And rather than jump straight into the questions, first establish what is going on in this table. So first decide, okay, I've been given a set of inputs and outputs. Obviously, that's important. Let's see what the pattern is. So when I say let's see what the pattern is, I mean, let's go and have a look. How am I getting from an output of 3 to an output of 1 while I'm subtracting 2? An output of 1 to an output of -1, I'm subtracting 2. -1 to -3, subtracting 2. And so hopefully what we see is that we're consistently subtracting 2, which means that I can continue this pattern for the 5th, 6th, 7th, and 8th terms. So this would be -7, let's try that again, -9, -11, -13. So guys, before you even start jumping into the questions, look at the information that's given to you, whether it's a diagram, whether it's a table, whether it is, I don't know, some sort of graph. Look at that first. Make sure you understand what's going on and then answer the questions. Because if you understand what the information is telling you, the questions become easier. So now when we move to these questions and the first question is asking us to describe the pattern, we don't even have to think about it. We've looked at the table, we've established what the pattern is, we can go and do that. So we can see that we are subtracting 2 each time. I know some of you prefer to say adding -2, that's fine, so I'll write both. But either way, we've established what the pattern is, and we can now describe it. And that's all because we didn't rush into our questions. We just took a second, we established what was going on, and then we went from there. Right, so here are nice, we're subtracting 2. Okay, guys, so that's the first bit. We need to be able to describe a relationship in words. Here, I'm subtracting 2. I'm decreasing by 2 each time. And now we know we have to be able to do is we know that we have to be able to find a rule. Now remember, when I say an algebraic rule, I'm talking in terms of x and y. So I want you to give me a rule where we've got y equals and then something to do with x. Okay? Maybe let's not do that. So something to do with x. Now, I've told you this already, but the trick or the starting point for finding any algebraic rule is to take the value that you know you are adding or subtracting each time when you are adding or subtracting the same thing. So when you have what we call a constant difference, the trick is to take whatever you're adding or subtracting and multiply that by x. So we're going to say -2x. So again, if your pattern is adding or subtracting the same value each time, you can start by finding your rule by saying whatever you're adding or subtracting each time times x. So that's our starting point for these sorts of relationships. We then need to just double check that we're on the right track, and we need to double check that there's nothing I still need to add or subtract from what I have so far. So we do a quick check or a quick solution for ourselves. If we take the first set of inputs and outputs, we know that x is 0 and we want an output of y equals 3. This is a very thick pen. Let's just sort that out. So if I now substitute in my x value into the rule that I've written down, y equals minus 2x. So if I now sub in x is 0, I get minus 2 times 0. Now minus 2 times 0 we know is 0. But importantly, that's not what I want. Okay? Remember, what I want is positive 3. So the question is, what do I add or subtract from 0 to get to 3? And exactly, we are going to add 3. Now we just double check ourselves because, again, we never just want to go in like a bull in a china shop. So we just do a quick check. If I take my next set, I've got x is equal to 1, and I want an output of 1 as well. If I now take my rule, y is equal to minus 2x plus 3, and I substitute in for x, y is equal to minus 2 times 1 plus 3. And so that is equal to minus 2 plus 3, which is 1. And so what I've established is that this rule that I wrote down is correct. Now remember, guys, a rule is very, very useful to us. If you think back to number patterns, and again, this is why I'm saying go watch those videos, we can find any input and any output as long as we've got a rule. We can use substitution, we can solve the equation, and we can get the value that we want. All right, so a rule, very, very useful to us. We're also going to see that the rule relates, or the rule gives us an idea of what the graph is going to look like that describes this pattern. Okay, I'll come back to this for screenshots later. But what we want to do now is we want to draw a graph. Now, guys, remember, in order to draw a graph, what you want is you want your inputs and your outputs, and you want to plot those points. I'm just going to move this table down so we can actually use it, because now we're going to draw a graph for ourselves that's going to represent this relationship that we've now described. Yeah? Right, so I'm going to say what I said again about inputs and outputs and coordinates. Remember that whenever you are plotting a graph or drawing a graph, you always want to have an x and a y value. This is what we call a coordinate. Now, because you've got a table, you have got all of your coordinates already listed for you. I don't necessarily have to give you a table, so Amahle, in answer to your question, I could then just tell you that your input is x equals 3 and work out your output. I could give you an input and an output and not a rule and ask you to find the rule, definitely. So we need to be able to work with these things. But right now, I've got a table, I can write down my coordinates. So if we write down our coordinate pairs, if we look at the first one, x is 0, y is 3. We go to our second coordinate, x is 1, y is 1. And so we can keep writing down our coordinate pairs so that we know exactly what points we want to plot. Okay, now we don't have to write down all of these coordinates. It becomes a bit time consuming. So I'm going to stop here at 4, -5. It's enough for me to draw my graph and get a shape. All right. So remember, guys, on your system of axes, we have got a y-axis and an x-axis. We know that the point where those axes meet is our 0, 0 point. We call that the origin. Anything to the right are our positive x coordinates. So these are all positive values that I'm working with. Anything then to the left of that origin point is negative. And our y-axis works in a similar way, in that anything above the 0, 0 point is positive. Anything below the 0, 0 point is then negative. Again, grade 8s, please remember that if you have questions, you can put them on the chat, or you need to wait until I ask you to raise your hand. Right, so there's our Cartesian plane, or our state of axes. We now want to plot those points. Right, I'm just going to do it in different colors so it's quite clear what's going on here. If we now go and plot those points, we start with, you can actually start wherever you want, it really doesn't matter, but let's start with 0, 3. So we go to 0 on the x-axis, which is at that origin. We go up to 3 and we plot our point. Our next coordinate is at 1, 1. So I go to 1 on my x-axis, up to 1 on my y-axis, and I plot my point. And so I keep plotting my points according to the coordinates or the input and the output values I determined from my table. So 3, -3, 4, -5. I could keep going, but I'm sort of reaching the end of my Cartesian plane, so I'm stopping. I can also sort of see what shape my graph is. I can see well enough that now when I join my points, whoopsie daisies, I am going to have a straight line. Now remember, guys, we always put an arrow on the end of our straight line to show that it could technically keep going forever. I could keep going to positive and negative and infinity on my x-axis. And so we draw little arrows on the end to illustrate that. Now, again, this straight line comes from the fact that we had a constant difference. So constant difference means that we're going to eventually have a straight line graph. I will make this a little bit bigger for everyone to take screenshots, but that's essentially what we have. Now, another thing I want you to notice is that right at the start, we said that our constant difference, or the thing we were adding or subtracting each time, was -2. We incorporated that into our equation. And now if you have a look at your graph, firstly, that negative is shown because the graph is decreasing from left to right. Who knows why it made that choice? Let's try that. Decreasing from left to right. We always read a graph left to right, always. And because the line's going down, decreasing. That comes from the negative. The 2 that we worked with, if we go from point to point, I can see that I'm going down by 2 blocks each time. And so this is my decrease of 2 units. My constant difference of -2. Right, and guys, I'm going to answer the question. I'm mid-sentence, just wait. So what we need to realize is that from the equation, we're able to get our graph, but we are also able to look at our graph and we're able to see what the relationship is. Right, so yes, when we are joining a line, if the dots all form a straight line, you take a ruler and you draw a straight line. However, the lines do not always have to be straight. Sometimes they are curved. We will do an example of a curved graph, but we can see very clearly here that this will be a straight line. Sometimes they are curved. We will get to an example. Right, take your screenshots. If anyone has any questions, you can raise your hands now. Otherwise, make sure you get in screenshots, and then we'll have a look at another example. Simongile?
Ma'am, I was asking if the constant difference will always be the same numbers or the numbers change.
So just to make sure I understand, are you saying, or are you asking rather, that if it's a constant difference, will these values over here always be exactly the same? Is that your question?
Like maybe for example, maybe the constant difference is -2. Can the other one be -3, or it will always be -2 until infinity?
So it will always be -2 infinity, and that's why the line is then straight, because it remains exactly the same. It remains constant for the whole pattern. But sometimes, and this is where the curved lines come in, sometimes we're not adding or subtracting the same number each time, and then we just have to be a bit careful. But if your constant difference is the same, then yes, it will carry on being -2 all the way up to infinity.
Okay, thank you, ma'am.
Sure. Right, I hope we all got screenshots of this first bit. Here is your graph for you to take screenshots of. And then we'll have a look at another example. Alrighty. I'm going to change the numbers in this table, so don't get too excited about this just yet. Okay, that's right. Let's hope. Okay, so again, we've been given a table. First thing that we do before we even look at the questions is we figure out what our pattern is. So we go to our outputs and we decide what's happening. So I'm going to give you 2 seconds. Have a look at your outputs, and on the chat, tell me what you think the pattern is. I don't need a rule, nothing like that. Just what are we doing from one to the next? If the pictures are not showing on your side, so if the screen isn't showing, you need to log out and log back in again. Good, grade 8s, well done. So what we can see is that each time we are adding 4 from one output to get the next output. So again, what we have is a constant value. So again, this is called a constant difference. Yes, we are adding, but we still call it a constant difference. Now, because it is a constant difference, if we go back to this first example, I said constant difference means it will be a straight line graph. So what that means is automatically in our heads, we should be thinking if I draw a graph, it will be a straight line because it is a constant difference. Right, so guys, on the chat, what I want from you is I want the outputs labeled here in the table A, B, C, and D. So continue that pattern for me. Please put all of them together at the same time. So don't send A and then send B, just do it all together. Tell me what the outputs are for the rest of the table. We know what the pattern is. Let's see. Good, well done. I like that numbering, A, B, C, and D. I'm going to give you another like 30 seconds. Okay, guys, good. So we add 4, we get 19. We add 4, we get 23. We add 4, we get 27. We add 4, we get 30. Oopsie, sorry. So we are 20. Oh, because I can't add 4, guys. 31. Thank heavens all of you are putting answers on the chat and I can correct myself. So those are all of our outputs. 19, 23, 27, 31 for the input values that we were missing. Okay, so now that we've got that, we can move on to our next question, which is asking us to describe the pattern in words. We've already done that. You guys have done that for me. We were adding 4 each time. Our constant difference was positive 4. Now we want to be able to express this pattern or express this whole relationship as a rule. So what I want you guys to try for me now is to try and come up with the algebraic rule that will describe this pattern. So remember, this should be in the form y equals something happening. I will give you a hint. It is not just y equals 4x. You probably need to do more than that. So have a think. And guys, take the rules that you're now putting there. So this whole y equals 4x minus 1 and substitute in an x value and make sure that you're getting the output. So just double check your answers. I'm not saying that they're wrong, but remember that we must always double check to make sure that we agree with what we're putting down. Keep those answers coming. Remember, we want the rule. Very nice, grade 8's good. So we know that we definitely have to start with 4x because that was my constant difference. I do a quick check for myself. If I take y equals 4x and I substitute in my first input, that would be y equals 4 times 0. I put too many equal signs there. And we know 4 times 0 is 0. I don't want 0. I want -1. So I have to subtract 1. And so that tells me that my rule needs to be 4x minus 1. So very nicely done, grade 8. So most of you, I don't know what's happening, why I've all of a sudden got some lines going on here. But anyways, very well done to those of you who put on the chat y equals 4x minus 1. Very nice. Okay, so now we want to draw a graph. So again, I'm going to just take this table and I'm going to move it down so that we can actually see what we're doing. Again, grade 8s, you don't have to plot all 8 points. It gets a little bit time consuming to try and plot all of them. And so there's no need for it. As long as you plot 3, maximum 3 or 4, you will be able to see what the shape of your straight line is going to be. When we get to graphs with curves, we generally try and plot a few more points, but we'll get to those sort of graphs just now. All right, so there's our table. We are wanting to go now and plot these points on our Cartesian plane. And so that's exactly what we're going to do. I complained about this in the last class. I forgot my things. So let's just quickly fill it in. 1, 2, blah, blah, blah. If you guys want, you can start thinking about what coordinates you're going to need to plot on this Cartesian plane in order to represent the relationship described by both the table and the equation that you guys have just found. When I eventually start plotting my points, I will do them in a different color so that we can see exactly where our points are, and hopefully we can then start to see exactly what trend or what relationship this function or these x and y values have with each other. Okay, so the first coordinates I'm going to plot, if I go to, excuse me, if I go to my table is 0, 1. So go to 0 on my x, go down to -1 on my y, and I plot my point. The next point, 1, 3. So I go to +1 on my x-axis, 3 on my y-axis, and I plot my point. Now, of course, I have not left myself enough space. I haven't gone up to 7. But if we now go to 7, that point would be somewhere all the way up there. And that's my own fault. I did not give myself enough space. But what we see, I mean, even 2 points is enough to draw a straight line. So what we see is that we can now draw our line to get our graph. Let's see if I can draw a better line today. Didn't go much better. All right. There we go. So we have drawn our graph. Now, again, guys, there's a couple of things that we need to notice, and we have spoken about it, but now we've got a slightly different situation going on here. What we see is that from left to right, my graph is now increasing. That makes sense, right? If I go back up to my table, we had a constant difference of +4. I was adding 4 each time. I was increasing my value. And so it makes sense that my graph is increasing from left to right. We can also see that it's increasing by 4 specifically, because if I go to my graph and I go from one point to the next, I can see that I've gone up by 4 blocks. And apparently I can't draw numbers either. but I've gone up by 4 blocks over there. It's chaos. There we go. And so there is my increase by 4. So that's where my 4x came from in my equation. Let's focus. Right, so guys, when we have, and let's just go back up to this example, when we are subtracting or when we have a constant difference that is negative, our graph decreases from left to right. When we have, like what we had going on here, a constant difference that is positive, our graph increases from left to right. And again, we can now look at these graphs and we can start to say, okay, this is increasing, this is decreasing. It is increasing by 4, it is decreasing by 2. And we're able to visually look at a graph and figure out what the relationship is. Right, so take your screenshots and then we'll have a little brain break because I think it is well deserved. Kubelo, welcome. I hope you are managing. Remember, there are recordings of all of our lessons on Watobe's website with that you can go and have a look at. While you're taking screenshots, guys, if anyone has any questions, you can raise your hand. Or remember, you can always ask on the chat. I'm going to move down to the graph in a second now. Okay, going down to the graph for you to take a screenshot. Spongile, will x always be 0? It can change. It doesn't necessarily have to be 0. You'll see later on in like grade 9 and grade 10 and 11 and 12, where x is equal to 0, it is quite an important point on our graph. So generally we do have somewhere in x equals 0, but it doesn't have to be. No, you can actually use any input that you want to draw a graph. Right. Guys, brain break, well deserved. You guys have done very nicely. There's your math stroke. Here's your brain break. It's really not too tricky this week. So give it a try. Remember, first correct answer on the chat. We're going to pick on you to explain to us how you did it.
Let's do this, guys. So basically, you need to ensure that you get the correct answer, the correct number for the question mark. Okay, so you must make sure that you get the correct number and you put it on the chart. And the joke, by the way, I think it's fun. Which triangle is the coldest? And isosceles triangle. Oh, that's the joke, my people. So let's find what is that question mark there and put it on the chart. When you find it, remember that we have two flowers there and then one flowers on the second row. So that's just a hint. And remember, if that's Yolanda there as a leaf, okay, it means that there's many Yolandas. So those Yolandas, they have to have the same number because it's the same person. So you can't make Yolanda a 5 and make the same Yolanda a 6. If you decide that Yolanda is a 5, then all of it, yay! Chantal. Do you want to raise your hand, Chantal, so that you can explain to us? There we go, Charity. Explain to us. Well done, everybody. Most of you got it right. Chantal, you have to deal with her.
Good evening, ma'am.
Evening.
Ma'am, for the flowers on top is 10 plus 10 plus 10.
Good.
And then down it's 5 times 5 plus 9.
Good.
And so it's equals to 9 plus 9 plus times 10.
Yep, good. There we go.
And down is 10 plus 9 times 10.
And which operation do we do first?
We multiply first.
Excellent. What is 9 times 10?
90.
Perfect, Chantal. Well done. And so, guys, exactly as Chantal said, 90 plus 10 gives us that final value of 100. Excellent, Chantal. Well done. Thank you. Oh. Alrighty, guys. So not too tricky a brain break today. Clearly, I need to make them harder. But well done. Let us have a look at another example here and see some interesting types of graphs that we can get that are those curves that we were mentioning. Again, I want to change my value, so don't get too excited yet about the table. So when you guys start asking questions, I adapt, I change. Oops. No, that stays that. This will be. Right, let's stop there. Okay, so someone wanted the joke. The joke was, which triangle is the coldest? It's an isosceles triangle. Bit of a pun. Excuse me. All right, guys, let's have a look at some of these cool graphs. I love functions as a section, and especially when we start going above and beyond just straight lines. So if we have a look at this table, this is a bit different because now we've got fractions in our outputs and then they go into whole numbers. So 9 plus 9 is 18. No. Ibukani, BODMAS. You first do the times and then you do the addition. So 9 times 10 is 90 plus 9 is 99. You have to remember BODMAS. Alrighty. So guys, if we have a look here, we've got this table. We want to figure out what our pattern is. Now, this is a slightly tricky one, so I'm going to help you a little bit. I'm going to ignore. I'm going to leave the fractions out for a second. Tato's already on it. And I'm going to go and have a look at what is happening from 1 to 2 and then 2 to 4. Okay, so what I see is that from 1 to 2, yes, I'm adding 1, but that doesn't remain consistent from 2 to 4. Another way to think about it, as Tato has wonderfully said there, is I could times that by 2. 1 times 2, excuse me, 1 times 2 is 2. 2 times 2 is 4. Now let's go and check and see if that remains true for the fraction. So if I've got a half times 2, and I'm just going to do it here, a half times 2, we know that that's technically 2 over 1. When we multiply the numerators, we get 2. When we multiply the denominators, we get 2. And 2 over 2 is 1. So that's correct. That works. Let's see quarter. If we say a quarter times 2, so 1 over 4 times 2 over 1, 1 times 2 is 2. 4 times 1 is 4. That simplifies to a half. So that works. So what we're seeing, and this is what quite a few of you have been asking about, that constant ratio relationship. What we see here is that I'm now multiplying by a constant value. So that means we could technically go and work out our next inputs, our next outputs. Sorry, I'm talking nonsense. So again, I want you to tell me what A and B are in our table now that we know what our pattern is. I'm just going to put those in slightly thinner pink because that was a bit aggressive. So there's A, there's B. What are the values of A and B in this table? Now that we know what the rule is, excuse me. Good, grade 8s. Well done. So we just keep timesing by 2. If I now times 4 by 2, I get 8. If I times 8 by 2, I get 16. Right, so different sort of relationship. I'm not adding or subtracting the same thing. I do not have a constant difference, but I do have a constant product. I've got a constant thing that I am multiplying. Okay, so now that we have that, we can hopefully describe our rule. So our rule, as we can see, is we are multiplying by 2 each time. So when we want to describe it in words, we are multiplying by 2. And so again, guys, that means we could continue on this pattern. Right, I'm gonna leave the rule for a second. We'll deal with that in a tick or two. Let's now go and have a look at drawing this graph and see what sort of graph do I actually end up with when I do that. So what I'm going to do is I'm going to take this table once again, and we're just going to put it down there by our graph so that we can actually draw it. I'm actually not even going to use this Cartesian plane because otherwise my life is going to be complicated. Right, here's my table. We're going to draw, oh, come on. We're going to draw, or we're going to sketch this graph. Okay, so first things first, guys, we need our set of axes. Can't draw a graph without axes. So let's draw those in. I have made some choices about how I was doing this. So let's just see what happens. There's my y-axis. And, oh, golly. Clearly technology and it's not, I'm not doing well. And here's my y-axis. Okay, now firstly, what I want to just point out is it doesn't have to be a perfect symmetrical cross when you go and draw your axes. It doesn't have to be like, guys, why can I not do this? You would think this would be a straightforward exercise for me, but apparently not. So your axes doesn't have to be a perfect symmetrical cross. You've still got an x and a y, so there's still x, there's still y. I've still got negative values if I want them, but I don't have to have a perfect cross that is even on both sides. Right, I'm making a choice to draw it like this because I know what this graph is going to look like, and it will be easier if my axes are like this. All right, so what we see is we've got inputs that are negative, and obviously I've then made choices where I can't get all of those negatives on. So let's just stretch that out a bit. We've got -1, -2, -3. We have our origin point. We've got 1, 2, etc., etc. And we also have our values up and down our y-axis. Now, obviously my y, I'm just going to stop talking and try and get this in because apparently my brain doesn't function trying to do both at the same time. I don't need any negative y values. If you look at your table, none of those values are negative. If you wanted to extend this y-axis and put in 1 or 2 negative values, by all means, that's fine. But you're not going to need them because as we can see in our table, none of our outputs are negative. Right, so now I'm going to plot my points. Now, what I sometimes struggle with personally is I sometimes struggle to plot fractions. So I'm actually going to start with this coordinate over here, the coordinate 3, 8, and then I'm going to work my way down. It doesn't matter, guys. At the end of the day, you plot the points. So this was at, oh, guys, this was 3 on my x-axis, 8 on my y-axis. So I plot my points. I'm just going to write in the coordinate 3, 8. That was that orange one over there. If I now move to my next coordinate, let's pick another color, and I move here to 2, 4. That's 2 on my x-axis. Am I incapable of plotting a point, or is this just me? No, apparently I can't plot a point. I don't know. 2, 4. There it is. Crazy, crazy, crazy. Next one is then going to be 1, come on, 1, 2. There it is. Next one is going to be 0, 1. So 0, 1. Now, hopefully what you're starting to see as I'm plotting these points, I will do the rest now in a second. Hopefully what you're starting to see is that they're starting to get closer and closer together. They're also not a perfectly straight line, which is what I said we were going to have a look at anyway. If I plot my next point, we've then got the point -1/2. So if I go to -1, only half up to my point, I get -1/2. And now when I start plotting these fractions, it does become a little bit harder because a quarter is now sitting somewhere over there, and an eighth is going to be very, very close to our x-axis, so almost on it, but not quite. Now, hopefully, again, what you see is that this is not a straight line. My graph is starting to curve, and this is because, remember we said, if I go up again, we said right at the start, only if there is a constant difference do I have a straight line. This was not a constant difference. This was a constant product. So my graph has to look different. So when I now draw in this graph, I'm actually getting like a J shape, a curved line. I'll get it in the end. So when I draw in my line, I'm getting a curved graph. All right, so this is the type of graph that you will eventually deal with if you take maths from grade 10 onwards. This is what we call an exponential graph. And if we just think back to exponents, if I take these values over here, 2 to the power of 0 is 1. 2 to the power 1 is 2. 2 to the power 3, 2 to the power 2 is 4. 2 to the power 3 is 8. 2 to the power 4 is 16. Hopefully what you're seeing is that this directly correlates to what we have in our table. 0, 1. 1, 2. 2, 4. So hopefully you're seeing that that relates to your input and output values in our table. So again, this is what we call an exponential graph. You don't have to stress about it too much. You need to be able to draw something like that. But I got distracted now. Ma'am, I skipped 5. I don't quite know what you mean I skipped 5. There's no 5 anywhere. Oh, I see what you mean. So sorry. 5 on my y-axis. Thank you, guys. So my points would have to shift a little bit, but the general shape is fine. Thank you. I'm not going to redo it. But thank you. I did skip 5. Let's just pretend I did have 5 in here. It would be somewhere there. Obviously, guys, that's not correct. It's not to scale. And now I'm just going to annoy myself because, 5, 6, 7, 8. So this orange point would need to move. Might as well do it properly here. 3, 8 is there. And so my graph is still a curve. But let's just get our points right. There we go. Thank you very much. All right, so this is one of the curved shaped graphs that you can deal with. You need to be able to draw sort of any relationship, and you are going to draw a lot of these later on in life. All right, so what I'm going to do is I'm going to do that. If you want to take screenshots of that, please by all means do that. If you have questions, please raise your hand and ask me. Otherwise, we're going to have a look at one last really cool shaped graph to end off. And again, you will do the next type of graph as well as you move up in maths. Bruno Fairfoy looks so cold. Cuddled up there. Okay, I hope you've all got screenshots. Let's take a look. Oh, okay. Okay, I'm going to go here. If you want, you can look at that table and you can see if you can work out what the pattern is. Sibongile? No. Alrighty, guys. So if we have a look at this table, like I say, we want to figure out what the pattern is. If we go and have a look from input, from output to output, we'll get there in the end. I'm going from -9 to -4. So that is an addition of 5. Now let's see if that continues or if that pattern. Okay, there we go. Let's see if that pattern continues. So now from -4 to -1, I am adding 3. So it's not a constant difference because I'm not adding the same thing each time. From -1 to 0, I added 1. But now all of a sudden I'm going from 0 to 1. So I'm subtracting 1. Now, if you have a look, you've added certain values, you've reached 0, 0, and now you're going to subtract values. That means our next one is going to be a subtraction of 3 to get -4, a subtraction of 5 to get negative. Why am I not being able to do maths right now? -9. Sure, we got there in the end. Right, so what we can see here, excuse me, is that we are, Teto, well done. We are adding consecutive odd numbers. We started at 5, we then went 3, we then went 1. Those are odd numbers. They come one after each other, so they are consecutive. And then I'm subtracting 1, subtracting 3, subtracting 5. So what I'm doing is I am adding consecutive. So consecutive means one after the other. Odd numbers. And so if we wanted to describe that pattern in words, we would be able to do that. Right, so quickly on the chat there for me, guys, tell me what the output would be if my input is 4. So basically what I'm asking you to do is I'm asking you to find the value in this block over there in blue. If you carry on that pattern, what would you now need to subtract to get that output? Think about what your next consecutive odd number would need to be. Good. So we would have to now subtract 7. That's our next consecutive odd number. So we get -16. Very, very nice. Okay, so if we now draw this graph again, we're going to draw the graph. I'm going to put the table here for us so that we actually know what it is that we're needing to plot. I'm going to take that off again. Technology and I today, it's a real fight. Right, so again, I can sort of see what my inputs and outputs are. I can see what my axes need to look like. I need to go essentially up to -9 on my y-axis and from -3 to 4 on my x-axis. So, okay, now it's blue. We're just going to pretend that that's all right. So I'm not going to change it. And can't draw a line because you know that's where we're at tonight. Everything's okay. Line, not an angle, please. Thank you. Okay, there we go. So there's our axes. Again, it doesn't have to be a perfectly symmetrical cross. There's my 0 points. There would be 1. I'm just going to fill in my values and then I'm going to plot those coordinates. Now again, guys, this was not a constant difference relationship. So what that means is that my line is not going to be straight. It is only straight when I have a constant difference. Let's all be patient. I need to go to my negatives on my y-axis. And I'm now going to plot these coordinates. So the first coordinate that I'm going to plot, and you can really plot whichever one first, it really does not matter. First one I'm going to plot is -3, -9. Okay, so -3, -9 is down here at the pink dot. I've plotted my first point. Then I've got -2, -4, second pink point, 0, 0. So that's on my origin. I've also missed -1, 1. There we go. Then I've got positive 1, negative 1, positive 2, negative 4, and positive 3, negative 9. Now, guys, hopefully what you're seeing is this is symmetrical. My dots are symmetrical. They're a mirror image of each other. And so what I have again is a curve of my graph, and this is what we call a parabola. You don't need to stress about that. That's not super important at this point. But we have another type of graph that is a curve. And the reason it has the symmetry is because if we look at our table, the numbers repeat itself. We've got negative 9, negative 4, negative 1, negative 9, negative 4, negative 1. So there's a repetition of my numbers. They are repeating themselves. Now, this is because I get very excited about graphs. The equation for this graph would be y is equal to negative x squared. Now, guys, think about this. Whether you say negative 2 squared or whether you say positive 2 squared, you get the same value. And so this is why for 2 and for negative 2, we ended up with exactly the same output. That negative then came from the negative in front of x. So the square is allowing us to get that symmetrical shape, which is so cool. So some of you will have done stuff like this. Some of you would have spoken about stuff like this. This is technically only grade 10 work where you start to actually look at these really in depth, but we can ask you to draw a graph like this. And so when you see something that is not just you're adding the same thing each time, remember that it might be a curve. So Lunofefe, I'm glad that you are having a look at these. I'm hoping this is helping.